Okay, today we're going to start working with a few word problems, and I just want to kind of ease your mind. We're going to try to stick with some pretty straightforward ones as we get ready to move towards this test. And we're going to go straight to an example. This example I'm going to add in. This one is not on your notes page we're going to use in a second, so you may want to do it off to the side someplace. What if I had a problem like this? The sum of three consecutive natural numbers is 804. Find them. The sum of three consecutive natural numbers is 804. Find them. Well, this kind of actually goes way back to Algebra 1. Okay? You should have done some problems like this in Algebra 1. Now, first off, natural numbers are the counting numbers. Okay? 1, 2, 3, 4, 5, 6, 7, so on. So, if I called the first number x, if that's the very first number I'm looking for, what if they are consecutive? Oops, I left off my n. If they are consecutive, okay, what is the next one? X plus 1. And then what's the one after that? X plus 2. You remember seeing this? So if I wanted to do the sum of those three, wouldn't I add them together? So I would have x plus 1 plus x plus 2. I would add those three together, and that must equal 804. Right? And so then you would combine your like terms. 3x plus 3 equals 804, and solve, right? So 3x equals 801. That would be calculator work from there. Somebody have 801 divided by 3? What is it? 267. That is the first of the three answers. What are the next two? Yeah, you can just count. 268 and 269. Okay? Now, you may also see a good old-fashioned percent problem. Something like this one. $18 is 25% of what number? Something like that. Good old-fashioned percent problem. Well, once again, this is back to review. We want to use this old friend, part to whole equals n to 100. Our old proportion friend for percentages. Okay? Part to whole equals n to 100. And n is always your percentage, right? So don't I have a percent in this case? Right here. So that's going to go where n is. So I'm going to have 25 over 100. And here's the big question. Is 18 the part or the whole? Well, the question says 18 is 25% of another number, so it is definitely the part. And then, aren't we pretty straight on how to finish solving that? Cross, multiply, and divide. All right, I don't need to go through that. And the next, let's go ahead and go now to the actual notes page. Example number 1. You've accepted a job for which your annual salary will be $32,300. This salary includes this salary includes a year-end bonus of $500. You will be paid twice a month. What will your gross pay before taxes be for each paycheck? Now, this $32,300, sometimes we're going to use a formula and sometimes we're not. Sometimes we're just going to be good problem solvers. That $32,300 includes the bonus. So I need to subtract the bonus. You only get that once a year on the end. That's not part of your weekly paycheck. So that becomes $31,800. That is your salary before the bonus, right? Now, how many paychecks are you going to get a year? Aren't you going to get 24 paychecks, right? So what do I do now? Divide by 24. Okay, so that's just a simple division problem. All right, let's go to example 2. You've accepted a job that pays $8 an hour. You are told that after a 2-month probationary period, your hourly wage will be increased to $9 an hour. What percent raise will you receive after the 2-month period? Well, on this problem, first thing we want to talk about is how much did your pay go up? Huh? $1, didn't it? Didn't it go up $1 an hour, right? So my increase was $1. That was my increase. Well, this is a percent problem, and we're asked to calculate the percent. So if I'm using part to whole equals n to 100, where would the 1 go? The 1 is the part. Okay? The 1 is the part. The whole, we are finding the percent increase on what I used to get per month. So my whole is going to be 8. And then everything else is set up for us. Okay? So then we would cross multiply and divide to find my percent. All right? Okay, let's look at the back page now. And starting with example 4, this is a good problem for us to look at. This is kind of one of the classic rectangle problems, and I would recommend drawing a picture. You've got a rectangle. A rectangular kitchen is twice as long as it is wide. Stop. One of the things you got to do on word problems is read slowly. Twice as long as it is wide. So if my width is W, my length is 2W. Okay? And the perimeter is 84, right? So what's perimeter? Isn't it all the sides added up? Okay? So if this is 2W, this is 2W, and if this is W, that's W. So if I add up all of those, 2W plus 2W plus W plus W, if I add up all of the sides, it should be equal to 84. And we're asked to find the dimensions of the kitchen. This one's pretty easy, right? So what do I have here? 6 W's. 6W equals 84. Divide both sides by 6. W equals what? 14? That is the width. So then what would the length be? It'd be twice that, right? The length would be 28. Now sometimes they'll give you this problem and they'll give you the same amount of information and then they will tell you to find the area. How do we find area? Length times width. Okay? All right. Let's take a look at example 5 here. A plane is flying nonstop from Atlanta to Portland, a distance of about 2,700 miles. We don't have a figure here, but that's okay. After 1.5 hours in the air, the plane flies over Kansas City, which is a distance of 820 miles from Atlanta. Estimate the time it will take the plane to fly from Atlanta to Portland. Well, what we need here is a speed. Okay? Do you remember this old friend that you should have used in science? Distance equals rate divided by time. Okay? Sorry about that little mistake there. I said that wrong. Rate equals distance divided by time. Rate equals distance divided by time. Now, I have some information here. I went 820 miles in 1.5 hours, didn't I? So the rate of this plane is 820 divided by 1.5. Okay? So you use your calculator. Somebody tell me what 820 divided by 1.5 is. What is it? 546, we'll say 0.7. Okay? What is that? Miles per hour. Estimate the time it will take the plane to fly from Atlanta to Portland. Okay, now notice it didn't say find the distance or whatever. It said estimate the time. Okay? So, don't I need to change this thing around a little bit? Right? Rate equals distance divided by time. I would multiply both sides by t. T times r equals distance. The t's will cancel. And I would divide both sides by r. And so now I can find the time it takes by dividing the distance by the rate. So didn't they give me the total distance? 2,700. And I have my rate, 546.7. So you do your division, that gives you your answer. Let's see what we get here. 2,700 divided by 546.7. 4.94 hours. Okay? Now you'll notice example 6 says similar triangles. Do you remember what similar triangles are? Their corresponding sides are proportional. Okay? So if you have two triangles, I just want to kind of give you a little hint on this problem. If you have two triangles within each other like that, they are considered to be similar. Okay? So if I have a, let's say that this whole thing is whatever, 180. Okay? And then this little distance in here is 30. Okay? Well, then I know, and then let's say that this is x and this is 50, let's just say. I can set up a similar triangle's proportion. I can say that 180 that's the big length, is to, now if this is 30, then this thing in here has to be 150. 180 is to 150. All right. Now notice we went big to small. So then I would go big to small. Is the same thing as 50 to x. Okay. Now that doesn't speak to this particular problem, but that does show you the idea that you're going to use to solve a similar triangles problem like that one. And we're going to stop there for today.